Hey guys, and welcome back to another video. Today, I'm gonna talk about the big changes I've made in the past 2 weeks. It's been 2 weeks since my last upload now. Uh, so I'm just gonna get straight into it. There's a pretty big list here. Yeah, so I'm just gonna get straight into it. Basically, as you can see on screen here, what I'm showing, or what I was describing at the time, is me being able to move the camera and actually see the change. It's not very easy to tell the change. The only indicator you have is the sprite stack and the position on the side, on the debug text. So what I did here is what you're about to see in a minute is I made a grid module here, which was broken at the time, but I made a grid module so you could see the change in position, and as you can see, it's way clearer. But there was some issues with the way that I was rendering the surface because I can't render every single line, every single frame, because that's too laggy. I don't actually plan to take this grid module that I made here anywhere. I might keep it in the engine, but I mainly kept it as a data structure and just for quick testing the camera and such. Um, this also opened up another issue that I'll get into later. The only problem is because the surface is so large that the grid's rendered on, frame rates are just god awful. But that's a small issue, it can be changed. When I fixed the grid, it actually looked really nice. You're about to see that in a minute. Hold on. There you go. It looks really nice. Exactly how I wanted it to. So moving on, I next made camera shake because I was actually looking at things that I need in the game, and as you can see, the camera shaking now. It's a pretty simple algorithm. Um, it literally just offsets the camera by like the camera shake amount for however many seconds. Um, yeah, so that's quite simple to talk about. I don't need to jot on for that any longer. Next, we got particle module, and the particle module uh is another thing that you kind of generally need in a game engine. This is extremely performant. If I remember correctly, I'm with optimizations, I'm actually get up to 21K on screen, all moving, all updating every single frame, um, while maintaining 60 FPS. There's also an option in particle module to make it that normal particles can be spawned if the frame rate gets below 60 to keep performance, stable. Next thing is Blitz, which is an insane function, which I'll talk about more at the end. Um, I'm kind of just like low-key rushing here, so I can just talk about all the things that are happening on screen. Basically, when I was just doing some engine research on how other engines work, they use this philosophy or this layout called entity component system, which is what Unity uses. How you have a game object, you got a parent object, all that. That's basically what this is. And some guys made a module for it. I might make my own depending on the direction that I decide to take the engine, but I want to keep the engine pretty lightweight and unrestrictive, so I might not do that, but I'm considering it. Next thing is I'm going to add camera tracking, or I was going to at this point in time, and this brought up all the major issues that I said I would talk about later, which and later is now. Um, and that's basically the position updating for my camera system. It is horrible. My whole GUI system needed a rework, and I'm about to propose some ways in which the GUI system can be changed. I don't know what time this was. This was late as hell. Hold on, let me see. Okay, guys, if you don't want to hear it, skip to this timestamp because it is a pretty long explanation and it's pretty technical. I was basically mind mapping how my whole system works so I can implement a new one in a better way and basically learn from my mistakes. This down here is what I had before. I'm just trying to compare the two. And as I was writing about this one and comparing this one to this one, I realized um, potential optimization I can make, a potential big one as well. And I'm gonna mind map that, and then I'll show you guys because um, I'm not sure if it's ever been done before, but it has to have been thought of, and I'm sure that it exists somewhere, but there's a reason that it's not like a popular thing. So I'm gonna draw it on a new one, and then I'll get back to you guys. All right, so I have made my concept for my render thread system. That's what I'm gonna call it, by the way. So basically, I'll show you what I had. The last working option that I had was this one down here, where there's UI elements, which is an array, according to this color key here, which is an array, and there is current scene slash level elements, and then world space, screen space elements inside of that, and this changes depending on the current level slash scene. So when you load a new scene, this buffer is changed to the one contained within the scene, or I'll say this list, and then there's another list inside of these lists, and this in my head seemed really effective, but when comparing it to this one, it didn't, because you've got 3 lists that you need to sort by drawing, meaning you've got 3 different draw threads in different locations on the script, and having delocalized, I guess, like, or decentralized, I'll say, like drawing threads just doesn't seem like a good idea. Not necessarily for performance, but also just for coding. Bad practice is hard to locate because you expect everything to be in a draw thread, but it isn't, because it's in like the camera thread or the viewport, etc. And this was also using the main camera system that wasn't good. So yeah, and this is the new concept that I came up with yesterday. I've named each of these lists. They're no different to the ones that are up here, but I've just given them a name to refer to them specifically for the sake of ease. But I guess you could call this a dictionary, and this an array, and this is a GUI element. But yeah, these are just what I've called them for one, coding sake and naming sake, and two, just for clarity. So this one uses, instead of using an array full of GUI elements, it uses a dictionary. This is good because then all GUI elements are in a single dictionary and can be referenced from there, meaning the GUI service can do all the sorting and searching. Which I'll go into the advantage of that later when I come on to the next system after this. And this again uses the current level slash scene contained within the GUI element, actually. That's why I chose this to be a dict. Because inside the dict, you can have entries for each scene depending on the scene that's at hand, meaning that GUI elements aren't stored in the scene, which one is easier because then everything again is centralized into one list, one dictionary, whereas before it was each one had its own GUI service, which means that you'd also have to wait for the scene to load this up. That wasn't really a problem, but it just creates the foundation for a problem. And inside the scene name, the current scene name is entry inside that dictionary. You got a render group, which is just again a dictionary of hidden and shown elements. And you may be thinking, well, now I've got 2 lists, which I do, but I'm not actually drawing between these 2 lists because the hidden elements just isn't even touched by the main thread. Like they're in there to just store them, but they're not actually going to get iterated through. Only the shown elements are getting iterated through, meaning that everything is already on one list here. So everything's going to be iterated through this one list only. And then the GUI service can move these between depending on if it needs to. And then we've also got another list down here in UI elements as well, which is GUI that is not contained in a level or scene, which I just call global elements now, because these are elements such as the debug info in the debug service. It's in no particular scene, although it just needs to be rendered to the screen. Obviously, this can't exist with the world position because it's not in scene, so it's not in a world, it's just on the screen. But this is still rendered through the camera, the new camera system, not through the viewport. But I guess I'll decide that when I come to it. And again, this is the same thing, only if it needs to be hidden elements just aren't touched, only shown elements are iterated through. But after thinking for a bit, I came up with a new system that might be faster than both of these. The advantages to each of these, and the reason I'm changing, is one for performance and organization, and two also just because I haven't really I mean, I don't really have a plan for anything, so I kind of need a plan. So it's nice to consider all my options before just slamming it into code. Um, Regarding like calculations and why this might be faster, like I said, one is a single object. There's only two lists that are being iterated between in the same dictionary. Um, the only problem with this, though, then calculations wise, is that now elements are gonna have to calculate their position from the camera in world space themselves rather than the GUI service doing it when it draws it. Which is probably better because then that means a ton of positioning handling can be done just through the element and not through the GUI service and the element. If that makes sense, don't worry too much about it. But if it does, good. Whereas here, because everything was separated into world space and screen space element, I could just apply the camera offset to this group only, and then this would just be rendered by the position that it's given. So this means when I'm drawing, I don't even have to worry about its world position until it's being drawn, in which I can just subtract the camera offset in that specific drawing loop. Um, Although that, yeah, I mean, I've said it here, it's not a huge performance deficit. Um, having to calculate position on the element or calculate it on the GUI service is whatever. Because the position you have to calculate it either way. It's just how I do that. Okay, so I've just come up with this new one while I was describing this one. So same thing, dictionary for UI elements, the instance of a level in a scene, and then the show and hidden elements. These work the exact same. But now, as you can see, you've got a new one called the render buffer. And what the render buffer does is anything inside of it is just drawn to the screen. So elements are now not drawn through their dictionaries and their render groups, and then the element caches. They're literally just drawn through the render buffer, and elements are added or taken away through taken away the render buffer based on if they're a shown or hidden element, which means that now I'm not even drawing shown or hidden elements. I'm just sorting shown and hidden elements. So that means that all all GUI operations are done on a single list inside UI elements. Um, yeah, and the reason I think this would be so much better is because I can then add threading into this. I've described it all here. So in the system I'm describing now, there's different ways I can do this. By the way, let me number this. There's different ways I can do this. So I'll go over number 2 first, which is this bottom one. So elements are drawn to the screen if they're based on if they're in the render buffer, and then a thread called what I'm going to call the sorting thread will sort between shown and hidden elements in the instance of the level and the global elements. So that means the sorting thread will iterate between these two. Maybe not every frame, but when it's required to iterate between these lists and add them to the render buffer if they're shown, or take them out of the render buffer if they're hidden. And this means that elements, actually I'm not even going to say that. This means that basically the string is taken off the main loop, so that the main loop isn't doing all the sorting as well as the drawing. It's now just doing the drawing. It's just drawing what it's told. There's no sorting, and the calculation is still done on the position internally. The second system that I've got using the same sort of architecture, we'll say architecture, bit of a fancy word, but that's whatever. Elements themselves decide what group they're in. This means that I wouldn't need a render thread, but everything in this render buffer is still drawn. So that means that only when an element status is changed, say I press a key, and I tell that element it's a shown or a hidden element, only then will it decide where it needs to go, meaning that sorting isn't done every frame. It's literally only done when it's need to. But thinking about it, I could also apply that same logic down here, but it'd just be a lot more programming and potentially even less performance. So this system would work really well for a small amount of elements. like really well, and also just won't need the thread there. The only problem is if I don't do this, I won't have the infrastructure for dealing with large GUI objects, like a large amount of sprite stacks on screen, or a large amount of animated sprites, or tile sets, or text. So um, this one could end up being worse in the end, but good in the short. What's it called? Good in the short term, bad in the long term. Uh, what I could do is I could merge the systems. You could choose which one you want depending on if you know you're going to deal with loads of GUI objects, or if you know you're going to deal with barely any. Or I could just dynamically switch between the two. So only when the threads get to a certain amount of number will, sorry, not threads, only when the GUI elements get to a certain amount of number will the thread then kick in. The only problem now is just the threading itself. And basically, threading in Python is really, well, not Python, Pygames, a little bit different to how it would normally work, because you got the main loop, which is going at a frame rate, or it's not, and then you got the thread, which just goes at a Pygame, not Pygame, a Python like while true loop, which is good for like calculations, but the problem is you're then waiting for data to change, and that could potentially do a thread data desync, where the data that the thread's accessing is already different to what it had before. So basically, if I have in an array, I got the number 1, and I choose a thread to just keep adding 1 to that, and then get the main loop to keep subtracting 1. Now the main loop's got 0, whereas the thread now has 2, and now you don't know which one to pick, and then your game crashes, or you just have unexpected behavior, and that's what a thread data desync is, where the data that the thread access is different to what the data is now, what the data is going to be, or should be. Yeah, so there's that. So I'm just gonna have to test both, but that's probably a lot of time, but it could potentially give me more performance. And when I was thinking of this, I just thought, surely someone has thought of this, but I don't know. Someone might have thought of this and then just not implemented it because it's not sensible, but I don't have to present this idea to the Pygame Discord, because one, no one will probably watch it, and two, they'll probably tell me that it's not good enough, or it's, you know, not worth it. But I think it's fun to just test it myself, so I'm gonna find out, and I'm gonna get back to you guys when I have the system in place. Okay, so I at this point in time I had implemented the GUI system, the top one, by the way. It doesn't have threading, doesn't have any of the fancy stuff that I talked about, but it's there and it's implemented like as it should be. And FPS, I think at this point in time, was about the same, if not higher, until I made some big brain changes, which I am going to talk about in a second. But I'm currently waffling about something. Yeah, well, I'm saying something. FPS is basically really high when doing nothing, and no text is rendered on the screen, which is what I use as a baseline. Text not being rendered on the screen would just tell me how much the engine by itself would get. So that's what I use to measure like the FPS changes throughout. But when I moved, the FPS would drop to like 100, so it wasn't good, and you could tell by the speed in camera moving. Anyway, so now I discovered that I can use a function in Pygame CE called fblitz, which is basically you can basically draw loads of surfaces onto a single surface using C code instead of using Python. Like going through a list with Python, you can just run fblitz, which will go through the list in C, or whatever. It does whatever. It does some magic in C and blitz in C, so it's just way, way, way faster on the CPU than using blitz in a list, or just blitz. So yeah, that was really cool. I'm basically just gonna use this throughout wherever I can, using a bit of list comprehension there. If you know, you know. If you don't, List comprehension is basically like running code in a list. It basically just keeps it tidy and it's fancy and like no one knows about it, but it exists. Um, as you can see, frame rates absolutely crazy, 700. Okay, and then about 500 with text on screen. The text does slow it down, even though we made some of our changes, which I'll get onto later, maybe in another video. But when I did code profiling, found out that a lot of the time is spent rendering the text still, drawing it to screen. So there's definitely some optimizations that need to be made. Again, something's going on here and I'm waffling. Yeah, I'm just gonna skip into the next segment. Oh, wait, no, not waffle. So basically, what I did is it creates a render buffer every single time elements are added or removed from either the scene list or the screen list, or the global list. Very technical. If you really want an in-depth explanation, even more than the one previously, just comment down and I'm willing to write it or explain it way better. Here, I'm just trying different things to get even higher frame rates, but the frame rates generally stay the same. Anyway, I'll start talking about the next thing. Basically, what I did after this is I wanted to use IMGUI, which is basically like the most lightweight GUI library on the planet. It's written in C, it's used in everything. You basically see it in everything. You probably see it on GUI without even realizing what it's called, but it's absolutely everywhere. I'll put up a picture of what an IMGUI GUI looks like. Anyway, I wanted to use it because it looks nice and it's fast, but you need OpenGL support, which I had to implement using modern GL because it's a modern version of OpenGL, of the Python OpenGL. So naturally, I just converted the engine to OpenGL, but the performance was actually worse because I'm rendering everything to the render surface being the screen, and then having to render that to a texture, a quad on the GPU, and then to the screen, which is extremely slow. Having to create that texture quad and then render it every single frame actually just halves the frame rate. Goes from like highs of 1,000 to highs of 500, averaging about 300, 400. So it's not good at all. So I added an option in the engine config to turn rendering, GUI rendering on and turn it off. And IMGUI didn't work as well. It created this weird bug where it drew a triangle on screen. Never solved it, so I never bothered adding it. It also took away from the frame rate without anything actually being on screen, so I didn't even bother. But as you can see here, what the config looks like, me switching from OpenGL to default Pygame, so basically just the CPU. Yeah, okay, well, you can see the frame rates on the CPU, they're quite high. Averages of like 700, it looks like highs of 900. And then if we turn on OpenGL here, you see highs of 500, averages 300, 400, not good. But it's whatever. I've kept it in as a configurable thing because shaders, I'm probably going to use shaders at some point. Or someone else might want to use shaders, so, that's there. Next thing I added is tweening. If you know what tweening is, it's basically like lerping, which stands for linear interpolation, moving one point to another. Basically, what they use for like GUI animations, when you press a button and a panel slides in smoothly from the side. If you've used Roblox Studio and you've done tweening, it works the exact same way. So I'll just show you here what tweening looks like. Very simple, takes 2 lines of code to run a tween, because it just tweens a value and then you can put that value in a position. For example, I could tween a vector 2 from 0, 0 to 100, 100. Just move that point very, very smoothly. There's an issue here where the tweens are being updated multiple times per frame, which is causing the tweens to speed up unnaturally, but I managed to fix it. by making sure that it couldn't be added to the like tween buffer more than once. Very simple issue, very, not much to talk about, but I do have some things to talk about in the engine, or rather regarding the engine, towards the end of the video. I'm coming to the end of the clips. Managed to fill out 25 minutes of talking and yapping somehow. Yep, I thought this would be too long, but it's not. Anyway, I'm going to talk about the engine changes that I'm going to make. So, first on my list is I'm considering using PyPy, which is, if you don't know, let me pull up the definition of what PyPy is. So PyPy is basically a like a neo Python. It's like Python if it was good. It's been re-implemented for insane speeds using like Python optimizations behind the back end, which is coded in C. And it uses JIT compiling, which stands for just-in-time compiling. If you know, you know. I'm not even going to bother explaining that, but if you know, you can search it up. GIT compiler, PyPy, PyPy, search it up. It's about a 4 times boost to Python, 4.8 times in Python 3.7, which is the equivalent of Python 3.10, 3.9. No, just 3.10, sorry. Uses low memory, but that in itself won't speed up the engine. It will just speed up the Python code on the engine. Stuff like Pygame will not get any faster. Like the blitzing won't get any faster, but it will help with like for loops and whatnot. So it probably will get a boost. So I might convert that at some point, but compatibility with Pygame seems a little bit dodgy, kind of unknown. I asked people in the Pygame Discord, and they said it's fine, so I got to try it first. Python as well. I might use a bit of Python, which is basically the C implementation of Python. So you can use bits of C code with bits of Python to get like a middleman and get performance of C with the syntax of Python. It removes some bits like you have to do type definitions. So you have to like say a variable is going to be an integer or say it's going to be a string. You can't do what Python does, where it's indiscriminate and you kind of just assign the variables to whatever data type you want and change it whenever you want. Which, I mean, I don't really care. I prefer statically typed languages anyway, but Python's different and it's cool. At the moment, I'm working on a mini game for the engine so I can test the engine and see how it'd be used in a real game. It's a mini tower defense game that I've always wanted to make in Python. The original driving, well, my original motivation for making this engine in the first place is called Citrus Cat. It's in the same GitHub repo as the actual engine itself. And wrapping up here, some things I want to talk about is, do you guys prefer longer videos or shorter videos? Should I wait 2 weeks for a long video, or 4 days for a 5-minute update, whatever? I think longer videos better in my opinion. I don't really mind either way. But longer videos better because I can then make big changes without having to come back to update them in another video. Whereas an update would be one change across 5 different videos. I mean, it's up to you. What do you prefer? And would you prefer me like doing like motion graphics and stuff on screen to elaborate like concepts better? Or do you just like the waffle, just listen to what the engine's changed and just see the changes on screen? I mean, I don't know what you prefer. Anyway, thank you for watching the video. This one is a bit of a rushed one. It's a school night. It's currently 9, so I need to wrap this up so I can play some games on a school night. Anyway, thank you guys for watching. If you have any concerns, anything you want to say, put it in the comments, please. My comments are super dry. We need to get to 1 million subs by the end of the year. Anyway, thanks, guys.